tool you're going to need is called the torque wrench. So this will allow us to tighten certain bolts to the correct specs, because on a precision machine like this you don't want to tighten it always as tight as you possibly can. There's certain rules that about tightening, especially these 4 bolts out here on the outer side of the piston housing. This is actually called the liquid flow. We can only tighten those to 40 psi, or pounds per square inch. So that's where this comes in at the very end. This is just a set of Allen wrenches. You guys probably have silver ones on a key ring. Those are normal. Those will work just fine. I just do this because I drop things a lot, so I want all my Allen wrenches together. This is just like a ratchet, so when I'm turning a bolt, it allows me to turn them quicker. That's just a time-saving device. This is an extension for this ratchet. This is probably one of the other most important tools. This is called a retainer spring wrench, or retainer spring pliers, and all these do is pull apart a spring that holds on a bearing to a camshaft. That's the purpose of this tool. This tool can do what's called an inside opening spring, where the spring is closed and it opens it up to pull it off of the shaft, and it can also switch over to be an outside opening spring. If it's holding something inside a cavity, you can make the spring smaller to pull it out of the cavity. So that's the right kind for us to get. This is a crescent wrench. You know, for the various fittings we have on here, we need, they're different sizes, so instead of having a bunch of wrenches, we just have one crescent wrench. But it needs to be a good quality one, because mines don't like to see your tools break while you're in their mine for sparking reasons or things like that. You definitely don't want to skimp on your crescent wrench. Also because with some crescent wrenches there's a lot of play in the jaw, stuff like that. So a good crescent wrench is necessary. This is these are VISE grips. They basically will use these when we're working on the check valves. This is going to be like our third hand, right? So I'm going to have to be wrenching something with one hand, but I need, you know, I need a third hand to hold this check valve steady. So that's where this comes in. These just are Allen wrenches too. They just make this job a little quicker when I attach them to the ratchet strap, so or the ratcheting handheld. But those are the tools you need to take apart and repair a Hammonds pump. Step one is going to be releasing these pipes from our fluid housing. So we're going to use our crescent wrench for that. And these fittings are pretty easy. Once you get them started, you don't need to keep wrenching because they're not on there very far. Now I usually loosen this back one. I don't know if we can see it on camera, but there's the down tube going to the other 5 psi check valve. I loosen that one so I can swing it out of the way if it's not time to change that valve. Alright, so now we have it free. It's weird doing it on a table where it's not like All right, so now what we need to do is disassemble this fluid end, take this part off. And the reason I do that first is because I like to get the diaphragm out of its hole before we start taking anything else apart. So
No, para todos. Ahí vamos a sentir todo bien. A ver, otra cosa.
now you guys see how when I'm loosening these screws, the gap right here is getting bigger. That's because the springs inside here are pushing this diaphragm out, so it's giving it more room. So you just be aware of that when you're taking it apart. That it's going to try to shoot off, you know. And one thing I forgot to tell you, but that we talked about in the office, was the importance of having a mat underneath where you're working. Like I would want a mat right here because of these things being under tension. You know, there's a lot of springs involved and things that you don't want to fall into the dirt. You know, an unsealed bearing that you're going to see right now that runs this whole operation, the worst thing in the world is to have it fall in the dirt. And I'm embarrassed to tell you guys how many times it's happened to me. So on the way here, I was like, what's one thing I want everybody to understand? And the one thing is put down a piece of cloth or something underneath so this bearing in here doesn't fall out.
Okay.
Okay, so this is called the fluid chamber, fluid end. This is where all the magic happens with this diaphragm right here and this chamber right here. So you guys can kind of see through this hole right here.
Yeah, right.
Yep, right here. So this hole is both the intake and the output of this line. So fluid gets drawn up from the bottom into this chamber and then pushed out the same hole up through the top. And these two check valves point the same direction, so fluid gets sucked through this one and then this one closes and then it gets pushed through this one, and this one was previously closed when this one was open. So it can only travel one way. And the reason there isn't usually additive in here, you guys can see there's a little bit, but there's not a lot, you know, it didn't drip out or anything, is because this diaphragm always wants to push to the end of this chamber right here. So it doesn't hold much additive. So we'll get to that in a minute. So we're pretty much done with this part, other than the check valves. The check valves come next. Because I like to do one part at a time. I like to rebuild this part before I go and start messing with check valves. So now we're going to take off the diaphragm itself, and we're able to see what this diaphragm looks like after it's been in use. So this will be good for you guys to see. You can see how this diaphragm has waves in it and is partially deformed. So it should be flat like a plate, but part of what our additive does at full strength is deform and degrade certain rubbers, right? We know that's part of it, and honestly it's a part of all fuel additives, but this is why we replace it, because usually you'll see a tear right around this rib area just from it flexing. So its whole job is to flex like this 5,000 million times, you know, and over time it's going to crack and break. So that's why we do this part. But see how when I touch it, it makes black on my finger? Okay. Okay, that's how you know it's kind of old. So really all that is rubber degrading. So if you take it out and it's black like that, you know, hey, it's time to change. But in all honesty, they usually look way worse than this. They usually are tattered and they look like a old tire, you know. So this one actually looks pretty good. So I don't know how long this was in service, but it either wasn't working very hard, or our dosage on the additive was low, so it wasn't pushing a whole lot of additive. All right, so now down here is the screw that actually prevents this dial from turning. And now this screw, unfortunately, is easy to tamper with, and it looks like we have a fix for that, which is good. I just put blue Loctite on mine because not only could somebody tamper with it, but this has actually vibrated out before on me, and then what's it do? It turns my additive all the way up right away, because that piston is going to push it as far as possible. So this has vibrated out on me before. So I'm glad to see that you guys do that Allen key. And it definitely will help. But we got to take that out before we can pull this off. Now you can just take my vice grips. Pull this little knob off. And one other thing, in your pump up kit, there's always a new knob, okay? It's important to use the new knob. I have used this old knob again. I've used this old knob like what we were saying earlier. Use all the pieces in the pump up kit. The new knob is important because it breaks, you know, and then you don't know, like, where's this pointing at? You know what I mean? Where, what is our additive rate? We don't know. We have no idea. So, and now I'm probably not going to have another little dial in my kit. So use the one that comes with it. They will always come with it. Now we get to the fun part. So pull this cover straight off. There is going to be usually some dirt, depending on what kind of condition your machine is in. Mine always has a crap ton of dust in there. You know, it's just sandy, nasty dust. So this cover comes off pretty easy. Again, you can throw this away because there's a new one in the pump up kit, and part of the reason we don't reuse this is because the stickers tend to fall off, as you can see, right? So another couple months, this probably would have been falling off. We don't know what our additive ratio is. B, it looks like we don't give a care about our equipment, right? So it's all about how we look to the customer. Having this hanging in the wind isn't a good idea. All right, now you can see, I'm not going to lie to you, there is a ton of grease in here, and I'm sure that Hammonds did that because I've gotten Hammonds pumps rebuilt like this too, and they are very liberal with the grease, but they do that because not everybody cares as much about preventative maintenance as we do. Now, when I'm done rebuilding a Hammonds pump, it does not look like that, you know, and only because it doesn't need to. All you're doing here, think of this as like peanut butter. All you're doing is allowing a substance to have dirt stick to, right? And dirt is the enemy of reliability, right? Dirt in here is the worst thing in the world. I want to minimize the amount of dirt that goes in here, and having all this stuff in here is not a good way to do that. So usually the first thing I do is, only because it's the part I never want to mess up. So I always take off this snap ring. I want you guys to come look at it first in case you've never seen it. Right in front of this shaft is a snap ring. And that is what you have to take off in order to get this bearing out. Okay. Now, it is possible to rebuild it without taking the bearing off, but the dirt and grime that gets back there, it kind of negates or wastes all the work you just did. You know, you just put like clean oil in a dirty car. You know what I mean? It's not smart. So you come in, if you can see, there are two holes.
Okay.
On top of the snap ring, and I'll let you guys play with it when I get it out. So the snap ring is what's holding that bearing on, and now you guys can see how it actually looks. And the two little ends of this tool slide into those holes, and that's what gives you the leverage to spread it. So we never want to, if we didn't have this bearing would vibrate out, it would stop turning, and nothing would work. So now that we took this snap ring off, okay, and set this somewhere, you're not going to forget, set it somewhere, don't set it anywhere black, don't set it on the ground, set it, you know, if you have a tray that you guys can use, whatever, you put it in your pocket, just don't lose it, you know. So now, I want you guys to see what happens when you turn this dial now. So there's no diaphragm in here. You guys can see that we have the snap ring off. There's no diaphragm on this side pushing this direction. So if we turn it, we're not going to cause any damage now, okay? Because it says don't turn it because we're worried about this little diaphragm. As soon as this little diaphragm's gone and this fluid end is off, we can turn it and play with it, okay? Because we have to in order to clear the cam from this bearing, okay? That's the only way we can get that bearing off without hurting anything, okay? So that's what our next step is. We put this little cap back on, and in here is there's a flat spot that matches up with the flat spot on this shaft. So you want to marry those together and turn it like so in order for the springs to clear this shaft. And now we pull this bearing out. So all we did is turn this all the way out, fully closed, pull that bearing out, and now we can take that slack back off the springs, okay? So I'm going to show you what came out of this bearing. Now keep in mind, all of this grease was white when it was installed, okay? So this is a plastic kind of spacer in a way that sits in between the bearing and the housing. You can see that it's normally white and all the grease was white, but it's dirty right now, right? So dirt is the enemy, you know what I mean? That's what's going to shorten the lifespan of our parts. Here's the bearing itself. You can see that it's a pretty substantial bearing. This is the back. So remember I talked about the ability to change this pump out kit without pulling the bearing out, but this is, look at the front. That's the front. It's clean, right?
Yep.
And look at the back. The back is where all the dirt is, you know, so you kind of don't want to do all this work without taking the bearing out, because this dirt is just going to stay in there and get into these little crevices. So you can't really see it on the back, but if you guys see, there is a hole all the way around, right? So it's not necessarily a sealed bearing. It's still open to the elements. So grease gets in there and all kinds of things get in there. And if dirt gets in there, it might create heat. You know, it will definitely lessen the life of the bearings themselves, but the heat is what I'm worried about. Seizing a bearing, if something keeps spinning with a seized bearing, it can get red hot, you know what I mean? And if you're in a mine environment, you don't want anything that hot near a bunch of diesel fuel, you know what I'm saying? So heat is the main thing I worry about. So that's why we don't want to drop it in the dirt, because it is a pain in the butt to clean. And it more than likely you're not going to do a good job. And let's just say that does happen. Okay, it's happened to me. Like I said, let's say it does happen, and you try to clean this as best as you can. You know, you're over here like, oh my God, I can't believe I just dropped this in the dirt. You know, oh no, what am I going to do? You spin it around, you can feel the dirt inside. You're going to do the best you can. Okay, but you're going to order a new one. You know, you're going to put it back in and order a new one and get it back in there as soon as you can. You can see that the front side of the bearing has the words. The back side does not have any words, but you can also see right here on the flat spot of the bearing, there is a wear mark, and when you guys handle it, you'll see the wear mark. But the wear mark will always be in the front of the bearing, because that's the part that rides on, that the actual camshaft rides on. So if you're ever confused, just look for that wear mark and know that it is the front of the bearing. All right, so now we are done with this shaft part, okay? We don't have to do anything else to this. Now, just because I want you guys to understand it, the back side of this shaft, where this shaft goes into this fluid chamber, okay, there's about 4 different seals and bearings and spacers inside from here to here that keep diesel fuel from leaking out of this chamber, okay? That is not a repair you want to do in the field. So this plastic ring sits behind the bearing as a spacer between the bearing and this other bearing. So you don't want to have 2 bearings next to each other, right? Because they cancel each other out. So all this is a spacer. So it's very important. There is a spacer behind this bearing, in between this bearing and the back. So the next thing we're going to do is take this shaft out, but in order to do that, we have to take this middle rectangle of metal out, okay? And there's 4 Allen screws to do that. So there's 2 down here and 2 up here. And these Allen screws are usually pretty tight on there. And yeah,
Question.
absolutely.
On the instruction that comes with the repair kit, it says that before removing the dial shaft,
Okay.
you have to turn the dial to its utmost open position.
Right. And it does that automatically, usually because of the springs. So that's why I had this on there still. So if the face was still on, you could see that it was at 9. But if I tried to hold it over there, it would still work its way back. Well, it's not really doing it. Okay, so always turn it to its full open position before removing anything. And really the only reason for that is because the springs are under tension. So I can move it right here with my finger the same way as this dial. But the springs are under tension. So that's why it wants you to open it all the way up, is to lessen the tension, and this thing won't explode out, you know, into the dirt. There we go. Now these Allen screws have washers on them. Okay, they're split ring washers, but they're also locking washers. So that's one thing to be aware of while because you have to take these all the way out, and don't lose the washers. Right size. I bought these to make it faster, but I don't, no. So you can see that this does take some time, you know, in order to do it. And it's not something you want to necessarily hurry, simply because of all these little pieces. Like if you lose one of these screws or one of these, I mean, the washer won't down the piece of equipment, but if you lose the screw, it ain't gonna work. You know, it would work for about five minutes, and then it would break this housing off. So that's why, you know, I said it takes 2 hours, is because you don't want to be trying to hurry and lose something or forget something. So you guys can see that this screw has a little washer on it right here. It has a little screw, a little washer on it that's important. Because what's this thing do all day? It vibrates. It vibrates. So that's the reason that we have a torque wrench and specs on how tight to make everything, because I'm not gonna lie to you, I've had stuff vibrate off before where I'm like, oh, I probably should have done that a little bit tighter, or paid more attention, or not tried to do so much in one day, And I understand that these are not always in the most convenient position to work on. You know what I mean? Like I'm in heaven that it's up near my waist. Usually it's on the ground, and I'm having to lay down in order to get to those bolts, and it's a whole lot harder to work on site. So I get that part of it, believe me, and that's why take as much time as you need, because we don't have more of these screws in stock. You know what I mean? We don't have more bearings unless we do here, and it's still going to take time to get it to you.
Yeah.
So now we are gonna pull this housing off. I want to get this off first so you guys can see it come out. So once I pull this off, it is going to, I usually put my finger here to kind of lessen the spring tension, because I'm about to release all the tension, all the things holding the spring closed, right? So even though it's all the way open, as far as it will let it go, I'm still gonna, when I pull this out, allow it to move even more, and this is when it would explode the spring out. So see how when I let that go, it still moves back a bit. Mm-hmm. That's because I pulled this out. What do you guys see here?
Hold that to the camera. Oh, cool. Thanks. Too much grease.
Too much grease. Amen. Right? There's just too much grease, and grease attracts dirt. In all honesty, some grease is good. Like this, the crazy part is this grease is expensive. This is white lithium grease. I'm sure they get it by the truckload at Hammonds, but we don't need to use this much. You'll see the size of the tube that they give us for this pump up kit. It's less than this. So this is this can only go in one I guess we'll do that during reconstruction or reassembly, but this is the shaft part. So this is the actual piece that your knob controls, that stops. This little thing right here is what stops the piston from driving farther, right? So this little thing is the key to your performance. But I have had this piece break in half before, so it is definitely not foolproof by any means, and that's why you should use every part in the parts kit, okay? Because even though this doesn't look like anything can happen to it, it does get hairline cracks that you cannot see. And I have taken the shortcut before and put it back in there like, I'll save that other one for when I really need it, And no kidding, 2 months later, I'm like, why is my Hammonds pump not working? This piece is cracked in half and wide open. So now the next step is to take out, this is actually the piston and spring. Yep, this is the piston housing. So this is what the diaphragm is attached to. So if I'm moving it here, if you guys could see on this side, that's what is pumping when this shaft is turning. Remember, it turns kind of in an oval shape. So it's pushing this piece. So this piece is going back and forth and back and forth and back and forth. That's its whole life, back and forth, back and forth. So that's what actually drives the piston to push the additive in. So all you need to do is pull it back just a hair, tilt it out, and it'll come out with the springs on the front. And this is what your diaphragm screws into. So I don't know if you guys can tell, but there is dirt on these springs, okay? And that is because there's grease on the springs. If there was no grease on the springs, there wouldn't be any dirt there, all that's doing is weakening the metal, it's weakening the life of this piece of material. What I also want you guys to see is there's plastic pieces. So this plastic piece, I have new ones I can show you, but this plastic piece is actually called a bearing. Even though it's just a piece of plastic, it's called a bearing because all it does, it spends its life sliding, 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 sliding. So that's where you need lubrication, okay? That's where we want it. But it's not doing anything up here. You know what I'm saying? It doesn't need to be all crazy. But so this is a wear plate on the back here. I guess I should show you with the clean ones, man. This stuff's just something else. Now we're to the, remember I was telling you about the piece of metal that is easy to leave in if you're lazy or not if you're lazy, if you don't understand, okay? If you don't understand the severity of not replacing everything, this piece of metal, why would you replace it? It looks perfectly fine. It only has one job. It just sits there, right? But that piece of metal takes all of the weight, takes all of the tension, takes all of the impact, takes everything. And it's not a, there in America, I call it pot metal. Pot metal. I don't know what it's really called. I don't know if it's called that everywhere, but what it means is a certain kind of metal that is cheap, right? And it's a bad alloy, basically. That's what kind of metal this reminds me of. I don't know. So there's a couple ways to make metal things, right? You can CNC it out of a bigger piece of metal, or you can forge it with heat, right? Or you can cast it, where you melt crap down and cast it into a shape, right? And cast metal is always weaker than forged metal or CNC metal, right? And it's usually reserved for cheap things nobody cares about, which is unfortunate because this is cast metal. And I have, with Brett standing over my shoulder, rebuild a Hammonds pump, put this new piece in, and had it fail in 7 seconds, like literally immediately.
Really?
Immediately, this piece of metal right here broke. So I don't know if you guys can see, but there is a line right here on this piece of metal, okay? So that piece of that line goes all the way across all the sides of the metal, okay? Now that is part of the casting process. So that's where two parts of the mold came together that left that line, okay? So the one that broke along that line. Because that's the weakest part of the casting, right? So I went and I put this back in, blah, blah, blah. These three holes are holding that flat piece, right, where the dial is. So this thing is holding every bit of work that this pump is doing, this piece of metal is holding. And it does create hairline fractures, especially along this little line right here. And obviously even a new one had them, or was weak. So if you rebuild your Hammonds and watch it run for the first 5 minutes, you know what I mean, with the cover off, so you can make sure everything's working, because it could break when you leave. You never really know, but it does happen. So I just wanted you guys to know that this is a weak part of the system. now I'm going to show you how to clean this Hammond. So our goal is to get all of this old grease out of there and get it ready for new grease. The reason we do this is you can see that there's some dirt in the grease. It has been, you know, used, so we don't want to reuse it. You can see over here there is a big blob of it. Most of the greasing takes place over here on this side, so I don't know why it migrated itself on over, but we want to clean all that stuff out. So it's literally just get your hands dirty day and get as much out as you possibly can. Now, we're doing this in a mine. I get it. It's dirty. It's nasty. Do you have to get every little speck out? No. Are you gonna? No. But you want to make it as good as you can. And you know, that's kind of how we do everything. We do it the best we can, the best as possible. You know. So don't be afraid to get your, you know, your towel, napkin, t-shirt, whatever you're using. Don't be afraid to get it in here, because we want all this grease gone, and we'll replace it with new grease here in a bit. You don't want to use any solvent on this because of the bearing that I'm touching right now. You don't want to get anything that would degrade it, you know. But you see, I don't know if you guys can see, I'll point to it with my finger, but there's a hole on this side of the Hammonds, right? For another piston. But what's that hole let in? Dirt, right? Yeah. So if you got this whole thing full of dirt, yeah, the front's covered with this bad boy, right? But dirt's still coming in the side, right? So that's why less grease sometimes is better. That air movement is key to keeping A, the bearings cool, and B, the springs and everything need air to work, right? We're still going to put lithium grease in here. We're just getting the grease that is old out. So that's, you know, kind of what I did here. You can see this clean is acceptable. I'm not going to get into these little cracks and stuff. There's no way for me to do that. You know, likely. The likelihood of me cleaning it better than this in the field is not going to happen. But what did it take me? It took me 4 paper towels. So this pump chamber is, you want to inspect this, because you want to make sure that there is nothing in there right now that you're about to close back up with a brand new diaphragm, right? Because whatever's in here is going to get bounced around a bunch of times. If it's dirt, if it's a piece of metal, if it's the old piece of rubber. Remember when I touched the back of that rubber, it got black all over my hands? It was doing the same thing to this. I should have told you before I cleaned it off, but this whole thing was black with that rubber. So what's that doing? That's going right into the diesel fuel with our product, right? So is it enough to matter? No, but I don't want to add to that. You know, I just don't want to do that. I'd like to just be my product going in there, you know? So always look at your chamber.
Let me help.
Thank you very much. I appreciate that.
There it is.
Okay, so that is cleanup. Alright, so after cleaning, we've cleaned this entire thing out of the old grease, lubricants, removed the old parts, and discarded those old parts. There's nothing that we took off other than the bearing and the spacer that we're going to need to reuse. In order for us to have new parts, we have ordered the Hammonds pump-up kit. It comes with everything we need to rebuild the internal structure back to factory specs, is exactly what it says, I think, right there. So pump-up kit, inside this bag becomes everything you need. I have taken the parts out and already gotten them ready to go back in. So this is the crosshead guide. This is the first part you're going to reinstall when you start. And I want to point out something on the back. It's called an indexing mark. You can see this circle right here. That indexing mark mates or lines up with another circle in the housing itself, so you can't accidentally install this thing incorrectly. So you could, in theory, install it incorrectly, but you would know at some point that it wasn't fitting right. And if you didn't know, you're going to break it. So definitely make sure that this circle goes in the circle in the housing. It's very important. That just slides in really easy. There's no force needed. Slide it over till it meets its home, and you'll be able to feel when it is where it needs to be. So you're going to reuse the screws, the original screws you took out of the body, and we're going to put those in now. Don't snug them tight. Just get them finger tight, I would say. And I don't know if you guys, if this is common practice for you guys when you put things together, but if you're putting metal things back together, you always want to put bolts on opposite sides of each other. You never want to like put these two bolts in first and tighten them and then put these two bolts in. You kind of want to even out the stresses that this metal is going to feel, and the only way to do that is to put bolts in alternating patterns. And when you tighten them, you're also going to tighten them in an X pattern. So you spread the force. All right, so this crosshead guide just needs to be tightened down as tightly as you can get it. The specs call for 55 inch-pounds, which is a lot. So as tight as you can will work. If we have a torque wrench that'll go in there, we can use it at 55 inch-pounds. But for our application right now, we'll do it just as tight as we can. I want to point one thing out though, is just like I was saying earlier, we need to tighten in an X pattern. Okay, so we start with a top bolt, then we go to the opposite side low bolt, and then back up to the top, and then down to the opposite side low bolt. That is important, strictly for equalizing the stress. And you want, after you have tightened them all, you go back to one time. You go back and just check and make sure that all of them are still tight. Because when you do tighten bolts like that, usually the first two you tightened loosen up after you tighten the last two. So those are all tight and happy campers. So the crosshead guide is in. The next thing we're going to want to do is put in the actual shaft. So this shaft has little plastic pieces in the bag. It would come in the bag loose, and you wouldn't know what they were for. But they are actually called bearings, even though they're not what you and I think bearings are. These are called bearings, and they're very important. They are what makes this thing slide back and forth in its little home right here. Back and forth, slides on those bearings. So that's the whole point. So don't miss putting in these plastic pieces. It's super, super important that those go in. You can see on the back side of this bearing, it's nice and flat and flush. There is a wear plate on this side, and this piece is called a wear plate for a reason. This is where the bearing contacts the shaft, or this piston part. The bearing is in contact with this periodically throughout its cycle. So this is always consistently wearing on this bearing. So that's why it's a wear plate. So on the front side, you can see this little notch right here. This is actually what this shaft contacts in order to reduce or increase the travel of this piece to decrease or increase the amount of additive. So there is a lot of stress going between this piece here and this piece here. So that's why you have to replace every single part, because you might not know where everything is stressed. But these 2 points right here, this is the only thing that keeps this from moving, you know, at your desired setting. So now, before we install these, we have to lubricate them up. You know, we'll lubricate at the end too, but you want to lubricate now because you want to trap as much lubrication in between this crosshead guide and these wear plates as you possibly can. So inside the pump-up kit, they provide us with this white lithium grease that is incredible grease. It is great for many things, but this will use probably half of this tube. I'm sure that Hammonds uses the whole tube. We're going to use about half of the tube, but I'll show you guys throughout as we use it. So it does come sealed with no hole in it, and you're going to want to put a hole in it, but I wouldn't cut too much off because it can get out of hand.
You have a pair of little scissors?
Oh, I got them. Thank you though. So you just open up your grease, and remember, this little square goes out towards you because it needs to. We're just going to put a little squirt of our compound on the top and the bottom of the wear plate, or actually the bearings. So it doesn't need to be much, just a little bit to kind of get it in there. And then we're going to slide this piece in. And you can see how a lot of that stuff came off, but it still trapped some inside. So that's what we were going for. Now, I forgot a piece, so we are going to pull this back out because it needs springs. The springs go inside these little holes right here. These springs are nice and clean. You can see that they're pristine, not like the other ones. Doesn't matter, there's no top or bottom on the springs. They just need to go in there, and those just return it to its normal position after it's been compressed. Oh, and just to show you guys, I don't know if you can see, but there is some lithium. There's a light film on it where the grease did get in between the metal pieces. I don't know if you can see, but there is some on it. Okay, so that went in. You can see how it goes. It automatically gets pushed back all the way to this shaft, right? And it is very hard to pull forward. And that's a good way for you guys when you do take it apart again. You can see that the old springs were a lot more cushy. You know, they were very... Yep, no resistance. They're very easy to smash. You know, when they're new, it is, you know, it's hard. So just keep that in mind. If that's too easy to move, you need new springs. Okay. All right. So we got the square forward, right? We know that the springs are in. Next, what we're going to want to put in is on your shaft. There is a flat nozzle, a flat side of the shaft, and that is what your pointer clicks into, your knob clicks on. So you know you want that flat part to go towards the outside. So if we're going to reassemble it, it's going to go this direction back outside. But there's something I need to point out about this piece. So this piece has 2 holes on the top and 3 holes on the bottom. Okay, now it's very important that the 3 holes go on the bottom, because that hole right here in the middle is what your adjustment keeper screws into. So you'll know when you put this together if you did it wrong, because you'll try to screw this in and you'll be like, well, I want to go in, you know, it's just not going anywhere. So always make sure that the 3 holes go on the bottom, or you're going to have to take it apart again, and that's not fun. So I don't know if you guys can see it, but when I squeeze it forward, if you want to come in here and see, there's a hole back in the back, and that's what the shaft, that little thing rides into. Exactly. Yep, just like that. Thank you. So that's the hard part, is holding this under tension in order to get your bolts where they need to be. Because these bolts go into these holes, right? And if they're not 100% lined up, it doesn't always work right. So, and you can't use this knob to take tension off until you get it past this point. So that's the hardest part. And there's a way that you can use a screwdriver to kind of push through. Like you can put a screwdriver through this hole if your fingers are hurting, or if you're wearing gloves, or if this just isn't going to work for you. You can put a screwdriver through this hole and push on this plate. But I just use my fingers, but you can do it however you need to do it. But you basically have to compress this spring enough to get that shaft into the hole, and then put this plate on the front side of it. So that's the whole point. And now we're gonna put these screws back in. Remember the ones with the lock washers? Yeah. Those go back in. And you'll know if your plate isn't in correctly because the screws won't want to screw in, but they will come back to in line here in a minute when you start screwing them. Now again, these screws need to be pretty darn tight. But not directly at the beginning. You want to tighten them at the end. And you notice how I'm going opposite, right? Always opposite. Remember that. Like, that's the most important part. Always opposite. Let me find which way it is in. Yeah, and these ones, and the reason they don't require a torque rating is because of the lock washer.
Okay.
So the lock washer is doing the job after you make it tight. Here's a good tip too. These screws go the opposite way your brain tells them to go, so you would think that this would be tightening them, but since they're upside down, it's the opposite. Yeah, so these little screws are the most time-consuming part because they're machined so closely.
Yeah.
That this part takes forever every time. All right, so now that part's in. So that is our guide, and our actual, the piston, the crosshead, I guess is what they really call it. So now what do we have left? We have to put on our spacer and then the bearing to put those two things back together.
Okay.
So here's the spacer. I don't know if I showed it so well in the beginning when I took it out, but this is what the spacer looks like. It used to be brown because of the old grease, but now you can see that it's actually white. And this is not a piece that comes in the pump up kit. This is something you want to make sure you don't lose. Now, could you, in a pinch, find another spacer that would work made out of plastic? I'm sure like we could limp, but until a new one came. But this, you remember when we took it out, we don't want to lose that part, and that just slides in there. We can lube it up a little bit, just because it isn't gonna hurt it, and it's better to have some lube on it than not. Because remember how much lube was in here in the beginning, right? Everything can have lube on it. And I don't want this piece to bind ever. Really, it's just keeping these bearings apart. So throw a little grease on there. Push him to the back. He'll line himself up when we throw the other bearing on there. Now, having a little grease on this isn't gonna kill it. It's gonna have some grease on it just from when you cleaned it. So don't worry about, super cleaning that before you put it back together. So put the letters facing you, and we're gonna grease this up a bit before we slide it back in there. And you know where it needs the grease because of the wear part, right?
Yeah.
So get that in there, ready to be pushed in, and then grab your new bolt or your new knob and get it out of the way. And then throw your bearing back in. Push it back as far as it'll go. Then take the weight back off of your knob. So that bearing is now reinstalled to where it needs to be. So we have a little bit of grease over here. Now, do you see this corner right here? See that corner? That is where we can put a bunch of grease. So gravity is going to continually pull that grease in onto this bearing, and it'll always ensure that there is grease in between the two. Now, you can put grease down here too, but I would never want grease over here. I don't know why they did that. Like, they put their big glob of grease over here. That's not helping anybody. You want to put it here. And if you want to put a big ass glob of grease right there, it's okay, because it's doing something there, but don't put it over here. Concentrate your grease where the stuff is going on, Let me think, what else here? Okay, so now we actually have to reinstall the diaphragm. So this diaphragm is the money maker right here. There's a screw on the back. Now, this screw sometimes is used if you don't want quite a full number 1 as your ratio. Like, if you need less than that, this screw you would unscrew a bit, so you'd only screw this into the housing less, so it would travel in the cylinder less, so it would be sucking and pushing less fluid. But we want the screw all the way down to the bottom. Okay, so make sure you look for that, because sometimes I've gotten them and the screw's been all the way at the end, and if you're not paying attention, you just screw it in. We're not getting 1 to 2,000. We're getting 1 to 5,000. Right? So this is the part. So you always want to inspect this before you put it in. Make sure it's not separated. This front plastic protective part. We don't want it to be separated from the rubber. I mean, really, you're just looking at it. You want to make sure it looks good, because this is the only time you're going to look at it other than when it breaks. So make sure it looks good. Over here is the shaft. I can't move. It's all right. That'll work.
Yep.
So over here is the actual shaft, the carrier that the diaphragm screws into. This is the chamber. So in order to not hurt anything, when we screw in the diaphragm, we want to get that part as far out as we possibly can, so we can screw in the diaphragm as far in as we possibly can. So by turning your knob, you're going to make that go in and out, okay? So we want it as far out as it'll go. Sit it right there. Hold it and screw on your diaphragm. Now, it doesn't need to be tight. It's not going to unscrew in there. It doesn't have anywhere to go even if it did unscrew. It just, it's not going to unscrew. So don't worry about, you know, tightening it down. Let's turn this back now. Thanks, brother. Got it?
Yeah.
All right, perfect. Okay, so watch what happens when I release it now. That diaphragm's going to suck back up to this metal part, right? So diaphragm is holding that cross guide, or the cross member, as far that way as it'll go, because there's no tension on this spring right now. So here's why they tell you not to turn this while it's not running, okay? So you can see when you turn it, it is pushing that diaphragm, and you have to remember what's on the other side of it, right? This big thing is on the other side of it right here. So if you turn this while it's not running, there is nothing helping you, because when it is running, this bearing turning helps alleviate some of the pressure off of these springs as this pushes towards this piece of metal. So if it's not running, there's nothing helping alleviate the pressure, and you're using all the force you can to turn this lever, and it could snap the lever, snap the housing, or push the screw through the diaphragm. So that's the reason why they tell you not to turn it while it's running, okay? So, but for us, it's okay to turn right now because it's not pushing against anything. As soon as we put this back on, we don't want to turn it anymore until our final set back to where it was originally, okay? So that's something you would want to note before you took it apart. What ratio am I running on this thing? You know what I mean? So, because you're going to put it back there when you're done, right? All right, so now I think, like I said before, we would lubricate right here, a big squirt, blah, 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 and then we'd lubricate down here as well. We need to put the spring back on, the snap ring. So this tool, again, it will make its reappearance. We slide the ends into the holes and put a little tension on it, otherwise it's just going to bounce off, right? And you don't want to put any tension on it until you're really, really, really close to it, because this thing will bounce and be gone. So you're just putting enough tension here to let it not fall off. Now what I do is I put my finger on the bottom and find the bottom, and then spread it and kind of push it on. And you can see that it goes right into its little channel that runs around. And I'll let you guys all try this piece, because we're in a controlled environment. We can find it if it jumps. But you basically just spread it till it'll go on, and then let it go, and it kind of knows what to do. It has a home. So after that, we're gonna find our new cover, and we're gonna put our cover back on. Put our new knob back on. And the last step is what's called our, what is this called? Our tension holder. So this knob is what keeps this from spinning. We put that in, but not all the way. We just want it in there so when we need it after this next process. So right now we are going to attach the fluid end to the diaphragm, and it will almost be back in service. So what we're going to do with this fluid end, there's a certain way we have to tighten the springs or the screws, okay? We always start in this hole right here, next to the S. And then we move to this bottom hole right here. And then this top hole, and then this bottom hole, okay? So that's why I told everybody about the X, is because we have to do that same X every single time. So we're going to do that now. So I want you guys to see, like, on the diaphragm, come over to this side real quick. I'm not going to turn it, but if you guys come over to look on the diaphragm side, if you look, when we put the screws in, okay, it kind of pinches that diaphragm, okay, and I want you to know that's normal, okay. So if you're getting ready to put this fluid end on and you feel it like catch that diaphragm, that's okay. Is how it keeps. That's how it keeps the fluid from squirting out the screw holes. Okay, so I just wanted you guys to know that that's something you're gonna see and feel and think, oh no, did I do something wrong? You didn't do anything wrong. That's how it was made. Okay.
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 But it does make it kind of challenging sometimes to put it back together. So when you first put these screws on, you just want to get them finger tight in that same order. So one of these screws lost its washer. I don't know how, but when I took it off, I noticed. So we'll need a new screw for this one. Just because this is also a lock washer. It's a different kind of lock washer. It is called a crush washer. And this keeps the tension on the screw just in a similar way that the other one does. So this screw doesn't have one and didn't when it got here. So I'm sure when they were taken apart in the mine, they lost it. But it's a necessary piece because the vibration of this machine will make this loose, and you don't want a leak right here because nothing's stopping the fluid. Nothing's stopping TPX from coming out all over the place. All right, so basically all I'm doing is putting a little bit of pressure to try to make sure that I get them all even. I think these are a different size, so that's good. Yeah, so. All right, so the torque value for the outside bolts is 40 pounds per inch. And I have the conversion right here. So 35 plus 10 is 40. Tighten her down. All right, so for Mexico, it will be 3.95 newtons.
Newton meter.
Newton meters, yep, 3.95 Newton meters. So basically all you do, it's just like a normal wrench at this point. I'll show you guys what it looks like and feels like right now. And you guys are all going to try this so you can all feel it, okay? So does anybody remember which one we start with?
The one by the S.
Top left S, exactly, good job. So we're going to tighten that one until we get to hear that click? Yeah. That was the click telling me that I hit my meters, right? My meters per inch. So I know that I move on to the next one. Hear that click? So that tells me that I'm there on that one too. Now, have I done this without a torque wrench? Yes. But it is dangerous because you can't be sure if you got them tight enough because if you get them too tight, you're pinching that diaphragm too much, you know, and you're gonna lessen the life of it because it's being pinched so hard and it's stretching, you know, so we're creating a weak point in it, right? So I have done it. If you guys don't have a torque wrench or it breaks or whatever, you know, you just want to get it to where it doesn't leak when you turn it on.
Word functions perfectly. Se va el que se fue.
And you just repeat the sequence one more time until it clicks, just to make sure. Okay, now I'm glad this happened, but I'm embarrassed. But I want you guys to come look over here and see the bad gap that I have in the meeting of the two halves, right? So
Yes.
that gap is crap, and that's not what we want. Our goal is to have it perfectly flush, right?
Okay.
So that just means I started on the top or whatever, and it was farther in on the top than it was at the bottom. So I didn't tighten this one enough to close that gap up. Even though we did it with a torque wrench and you think you're even, you still aren't. And that's what you need to check for, right? So when you put this back together, just like I did right now, and I say, oh, crap, that doesn't look right, you know that you need to take that piece back off and start over. All right now we are going to open the rear part of the Hammonds. This is rarely done. It's not necessary unless you can hear things. Because it will end up in the Hammonds pump. So this is a 1/2-inch bit. That's just on a ratchet. So I realized I forgot to say that. So
I could just put lower third, you know, titles and stuff.
you could, oh, okay,
Pop up, you know.
right?
You imagine you get that in your car?
Sí.
You want me to hold it or?
I think we'll just roll it and see underneath it. Yeah, you can. Perfect. That's perfect.
So this kind of tells people too that be prepared for leakage, right?
Yeah, absolutely. All right, so that is the inside of a Hammonds pump, and so think about that. The other side is being held. That the other side has a shaft just like this, right? And it's going out the hole. But you can see that this Hammonds pump is not equidistant from this side as it is from this side. All the action is going on down here where these veins are catching gravity right now, but this is where the fluid would be driving this in a circular motion, this travel right here. So that's the cool part about a Hammonds. But this one looks pretty clean, in all honesty.
Pull it out.
Yeah.
want me to?
Maybe just hold it.
Yeah.
No, not down.
Oh, not that.
Nope. There's fluid in the bottom. You gotta get it out a certain way.
Okay. Start with something.
Down.
I can put the.
No,
¿No?
él nada más porque lo estaba haciendo hacia arriba.
What's wrong? The fin?
I don't know
It's
what's.
not coming out?
No, not problem, this is outside.
Start with something. It's weird.
Wow. We didn't have that problem before.
Oh, okay, maybe there should be like a pin. No?
There's a pin right there. Here, let me pull these out. I can't grab. Get it?
Yep.
There we go.
Eso es todo lo que es el Hammond, ¿eh? O sea,
And there's nothing.
esas partes.
Nothing else.
Sí,
No.
eso es lo que yo quería que vieras.
Dude, that's so clean. Oh
Yes.
wait, no, it's not.
¿Qué pasa?
Y eso sí lo podemos limpiar con agua.
What's in there?
No.
Oh, it's just in him.
Imagino que tiene ahí
wow.
It was
Dice mucho
No.
limpio, mucho mejor.
Es la cuña.
Oh, I see it.
Fíjate que eso sí es cierto, porque me dijeron ahora cuando fue lo del derrame de diésel ahí, que ahora ese lo usamos como para limpiar.
¿Eh?
El diésel que se derramó. Me dijeron, "Ah, ese lo
Where it
usamos para
goes.
limpiar".
Back in the back.
Es que me imaginé una carcha.
No, sí,
Oh, there's another pin. No,
Yeah,
no.
way back there.
Sí, eso es para que lo
No, pues en dado caso que
What
necesites
did you
hacerle
find?
algo.
alcance a girar con.
This little, it might be a magnet.
Ooh, wow. Is that part of the Hammonds?
Yeah. It is a pin. It looks like it slides in and out though. This one slides in and out too. So, I think it just slides in there.
That was stacking the. Or not letting it out the.
Yeah, there we go.
Yeah.
Back to normal.
Huh?
But this is it. Like this is the only thing in here. So, but do you guys see? Like, look on the top right here. So remember, this was the piece closest to our bearing, right? And see all this crap that's in here too. And who knows, how much of that is getting pushed out through the other bearing or whatever. But this is a bearing too,
Can we see the other side of this piece? The other end?
Yep.
Together.